this video we're going to look at some composite shapes, but these composite shapes all involve circles or areas of semicircles. So in our first one, A, B, C, actually in our previous video on composite shapes, the first thing we did was separate them out into different distinct shapes that we knew how to solve the area for. In this example, they've already been separated into shapes for you. So we have a square here, which we'll call A1, and we have a semicircle here, which we'll call A2. So in order to solve for this particular question, what we need to do is work out the area of each and then add them together. So the area of A1 is pretty straightforward. So A1 is going to be equal to, well, what is the area of a square equal to? Well, it's length times breadth, or in case of a square, a perfect square like this, it's actually going to be equal to the side length squared. So it's going to be equal to 10 times 10, which is going to be equal to 100. And the units is kilometers, so kilometers squared. In A2, we're going to look at a semicircle. So a semicircle is equal to, well, it's going to equal the fraction of the circle times the area of the total circle. In this case, the fraction of the circle for a semicircle is half. So it's going to be half times the area of the circle, which is pi r squared, or pi times r squared. So what is r going to be? Well, r is going to be the radius of this circle. But we've only got this length here, but we notice that these two lengths are equal. And if we have a line that goes straight across from one side of the circle to the other through the center, we know that this is the diameter. And we know that the radius is going to be equal to the diameter divided by 2. So the diameter divided by 2 is 5 kilometers. So A2 is going to be equal to half times pi times 5 squared. Well, this is going to be equal to, let's bring up our calculator and we can do 1 over 2 times pi times 5 squared. Well, this equals 39.269. We'll round to two decimal places, and it's going to be equal to 39.27. We'll add our 100 to this later, so 39.27. Now, to get the total area, we simply add A2 and A1 together. So the total area is going to be equal to 100 plus 39.27, which is equal to 139.27. Check the units, it's kilometers, so area is kilometers squared. Okay, so let's do the next one. Just make some space. So, in this particular example, we have a semicircle and we have a trapezium. How do we know it's a trapezium? Well, it has two parallel sides in a quadrilateral. So if we have this shape, we know that the formula for a trapezium is equal to a plus b over 2 times h, where h is the perpendicular height. And a plus a and b are both of the sides that are parallel to one another. So in this case, 16 meters and 18 meters. So let's call this A1 and this A2, and let's solve for A1, which is the trapezium. So that's going to be equal to, well, 16 plus 18 divided by 2, and then times the perpendicular height. Now, what's the perpendicular height of this trapezium? Well, that's a bit tricky because we haven't been told. You might assume that this is maybe halfway, but that's not true. We haven't been told what the perpendicular height is, but we can figure it out if we remember that the distance from the center point to any point on the circumference of a circle is equal to the radius. So the distance from this point here directly up 90 degrees is equal to the radius. And we know that this length here is the diameter. So this length to the top, directly 90 degrees, is going to be equal to 8 meters. 8 meters, because that's the radius. Now, just remember, any point, any direction, from the center of the circle to the circumference is going to be equal to the radius. And this is the diameter. We divide it by 2, we get 16 over 2 is equal to 8. Right? So if we know this bit here is equal to 8 meters, now we know that this chunk here, which is our perpendicular height for a trapezium, must be equal to 20 minus 8 meters, which is equal to 12. So our area for our trapezium is going to be, well, 16 plus 18 is 34. 34 divided by 2 is equal to 17, times our height, which is 12. So 17 times 12 is going to be 204. We can check that in our calculator. 17 times 12 is 204. And that's in meters, so this is meters squared. And for our semicircle, well, we've solved these before. We've found out what our radius is. It's going to be 8 meters. So the area of our semicircle is going to be equal to, well, it's going to be 1 over 2, the proportion of the circle, times pi times 8 squared. Well, let's just add that on to our, let's do that now. So 1 over 2 times pi times 8 squared. So that is equal to 100.53. So let's just do 100.53. So our total area of this composite shape is going to be equal to A2 plus our A1. And we can just save what we've got here, which is our A2, and we can add on our 204 meters. So our total area is going to be 304.53 meters squared. Remember its area, and remember to add units. Okay, let's look at this last one. In the last one, we haven't been told how to divide it up, but if we drew a line here, we could see, well, it's a semicircle and a triangle. So we know how to figure out the area of a triangle. That's just going to be, so area is equal to half times base times perpendicular height. And we know how to figure out the area of a semicircle. What we don't have here, well, we have this distance here, which we're told is our 8 millimeters. So that's our diameter, but it's also the base of our triangle. We found that, but what's our perpendicular height? Now we're going to follow the same logic as we used for the last one. If this is our diameter, then our radius must equal half of our diameter. So our radius is going to be equal to 8 over 2, which is equal to 4 millimeters. And if we know that the radius can be at any point, we can go 90 degrees directly down, and this will still equal 4 millimeters. 4 millimeters. Now if we know this shape's perpendicular height, and we know the overall composite shape's perpendicular height, then we know the distance of our triangle's perpendicular height is going to be equal to 16 minus 4, which is going to be equal to 12 millimeters. So now we have everything we need in order to solve for our triangle and in order to solve for our semicircle. So we're going to call our triangle A1, we're going to call our semicircle A2. So A1 is going to be equal to, well, half times base, which is 8, times our perpendicular height, which we worked out is 12. Half times 8 times 12, so 1 over 2 times 8 times 12, which equals 48. So 48, and what's our units? It's millimeters. So millimeters squared. What's our area 2 going to be equal to? Well, we know that a semicircle is half of a circle. So the fraction we have to multiply the area of the circle by is a half. And then we multiply it by the area of the circle. So half times pi times our radius squared, which is, our radius is 4, so 4 squared. And we plug that into our calculator, and what we get is 1 over 2 times pi times 4 squared. And that is equal to 25.13 millimeters squared. Okay, so with these two figures, our total area is going to be equal to 48 plus 25.13. So we have 25.13 here, so we just add on 48. And that equals 73.13 millimeters squared. Alright, so that's how you solve some quick composite shape questions involving area and involving circles. Hopefully this was helpful to you, and I will see you in the next video.